Hello. Well, this is a short video of my first attempt at model engineering. The model, as a lot of you will recognise, is a Beem engine, and I bought the castings from someone who had actually made a start on the engine and had actually machined the cylinder, and a good job he made of it as well. But I've then gone on and machined the rest of the components to end up with a working machine engine. As you can see, it's not painted yet, and in fact it's waiting for a final polish up, but this is just a first attempt at getting everything together and making sure that the thing actually runs. I'll also describe a couple of the areas of problems that I found in the design as I go around, but I thought first of all we'll get the thing moving. So at the moment I've got it connected to an air compressor, and it's running at about 10 psi, between 10 and 20 psi actually. And if I just introduce some air, then as you can see the thing is running and reasonably slowly. So I think actually that's probably at the bottom end of the pressure range of about 10 psi there. Some of the difficulties I had with the design was that, as it was the very first engine I had ever built, tolerances were something which are not specified on the engine, and I found very difficult to understand. So at first everything was made to the dimensions and everything ended up being really tight. However, with a little bit of running in, the thing is now reasonably smooth. So what I'm going to do is take you around some of the components and just show you those. There'll be many people who know all about the components on a steam engine, but maybe there's one or two that are looking who have not seen a steam engine run before, so I thought it would be worthwhile just giving a quick introduction to the components. So, the various components of the engine. Primarily these engines were designed to pump water out of mines, and the pump is here. I haven't finished the pump completely, but there's got to be a pipe coming from here which loops round. Obviously this end is the cylinder, and this is the valve system here. What happens is, as the valve comes up, it allows air to, or in real case steam, to go on top of the cylinder and force the cylinder down. Then conversely, when the valve is at the bottom, it allows air and steam underneath the cylinder to push the thing back up. Here is the parallel motion mechanism, and the parallel motion mechanism is designed to provide a vertical travel for the piston rather than following an arc, which it would do if it was linked directly to the beam. At the back of the engine we have the governor system. The governor operates via centrifugal force, and as that throws the balls out, it lifts up the lever that you can just see underneath the balls. At the moment I've made the throttle, but I haven't connected the throttle up to the engine. I'll now take a look at some of the, we'll do a close-up of some of the individual components. I'll just stop the engine and we'll have a look at the clearances that there are. This is a close-up of the parallel motion mechanism, and I can just point out one of the problems I found on the design, and that is that the clearance between the crosshead here and the links here was insufficient, and if you just calculate all the sizes, you find that they actually do touch. I got around the problem by reducing the thickness of the lugs on the end of the crosshead from what was in the design 1/16 of an inch down to 1/32. I also reduced the size of the boss on the pin which comes through here, again reducing the thickness down to about 1/32, and that then gave me sufficient clearance and the thing runs. What else did we find? One thing I did find particularly difficult was making sure that the piston rod, that the slot in the top of the piston rod was in the right place. May sound obvious, and I suppose it is obvious to anybody that knows what they're doing, but I just put the slot in at a rough position because it wasn't dimensioned on the drawings. I then had to adjust it slightly once the thing was in situ. There's only about 40 thou tolerance in where that slot can be, otherwise the piston either hits the top of the cylinder cover or it hits the bottom of the cylinder. So that's pretty critical. In fact, a lot of the dimensions are quite critical. Moving around and looking at some of the other components on the engine, what you're looking at here is the obviously the gear mechanism, which drives the shaft for a takeoff pulley, and also the eccentric. The eccentric is this brass thing here. And you can see once we start operating the engine, the eccentric does what it says. It moves in an eccentric circle, and the action of that, of course, is to move this rod here back and forth. And that rod operating back and forth links to a cross shaft, which then operates the valve mechanism. And I'll show you the cross shaft in a second. Unfortunately, the video camera that I'm using doesn't focus or doesn't adjust its focusing automatically, and the only way to focus is to stop the recording and then move on and refocus on the subject that you want to focus on. That's obviously the governor, and you can probably just hear in the background the compressor, which has come on now and just pumping up. So let's have a look at the cross shaft and operating the valves. This is the link which connects to the eccentric, and it's pushing back and forth on this lever here, which then in turn is operating this shaft, onto which are attached the cranks, which then drive the valve mechanism up and down. Not sure why this is a fancy handle, it's what it was in the design, but yeah, I presume there must have been a reason for it, but maybe somebody that's more enlightened can let me know what it is. Anyway, that's the engine in all its glory, chatting away. The next job I've got on the engine now is to paint it, and also have a bit more of a clean up on the castings and things. I've taken a series of photographs of the build, and if anybody's interested, then follow the link in the instructions there, and there's quite a few photographs, a couple of hundred, which I've taken really for my own benefit to remind me how I machined some of these parts. As I say, this was the first build I've done, and I found taking the photographs quite useful to look back on and think, oh yeah, that's how I did that, or that's not how to do it, because there were definitely one or two things where there were better ways to do it, and I know those now. Anyway,